Now the second thing we want to take a look at is whether the form of the model is correct. Is that line that we hypothesized the correct model to use? And we are going to evaluate that according to 4 regression assumptions, and these 4 regression assumptions are assumptions that you have to memorize. I will ask you to identify the 4 regression assumptions on the exam and take a look at whether these assumptions are satisfied. The 4 regression assumptions deal with the residuals, and the residuals, once again, are the error terms that are left over around the model, the deviation between the points that we have observed and the model themselves. These red lines that I've just drawn are the residuals. Adding them all together gives us the total residuals. Now, when we take these residuals, we are going to effectively rotate this line until it's horizontal. We're going to bring this line down to the red line, bringing all the points along with it, and this will give us a plot of the residuals that we can evaluate. We'll take a look at our sample in a few minutes, but what I want to look at first are the 4 regression assumptions. Number 1, the residuals are independent. Number 2, expected value of the residuals is 0. Number 3, the variance of the residuals is constant. And number 4, that the residuals are normally distributed. So let's take a look at independence. What we're looking for the first assumption, independence, do patterns exist? Now this is a sample that I've given that actually does have a periodic relationship that we haven't modeled yet. And if you look at this carefully, you can see that the residuals do go up and down, and they follow an up and down periodic pattern. There's so many of these that it's a little difficult to see this at this scale, but the pattern does exist. This is a violation of assumptions, of the independence assumption. And what this is really telling us is that there is an additional pattern that we can model. Second assumption, expected value of the residuals should be 0. Well, if you add all the residuals up, you do come to 0, so because you are measuring about an expected value or about a mean. So what is this really telling us? Nothing overall, but when we break up into sections and take a look at the residuals, we see that all of these residuals are below the line. All of these residuals are above the line. All of these residuals are below the line. And in fact, when we take a look at this, we can see a very distinct pattern in the plot of the residuals. This is not what the residuals should look like. What this is telling us is that we should have used a curve to model this particular data set versus a line. When we use the line to model the data set, it doesn't account for the curve, and the expected value here is not 0. Third assumption, the variance is constant. As we move from left to right, does the variance increase? Does it decrease? Does it remain constant? We need to see constant variance. Taking a look at this set of residuals, we've got a great deal of variance in this range. And as we move from left to right here, the variance seems to decrease. In other words, the residuals approach the horizontal line. There is less variability around that horizontal line as we move from left to right. That is a problem for us as well. It's going to become a problem when we try to use confidence intervals to estimate where our actual observations are going to be. So when we take a look at this, we don't want to see patterns like this in the residuals. We would like to see all of the residuals evenly distributed between 2 parallel lines. The fourth thing that we're going to look at, or the fourth assumption that we have to test, is whether the residuals are normally distributed. Now we will take a look later on next week at how we actually get the residuals, evaluate the distribution. We're going to focus on the graph of the residuals, or the histogram initially. Taking a look at these residuals, you see that you've got some residuals with negative values and some with positive values. Here is 0. The red line that we're looking at is a normal probability density function superimposed on a histogram. And when you compare the histogram to the normal curve, you see that you've got a pretty good mismatch. So if we're looking to see if these residuals are normally distributed, the first place we're going to see a problem is histogram versus the normal curve. Second area, we've got a normal quantile plot. And the way a normal quantile plot works is it gives us a diagonal line and it translates the observations to quantiles. And what we're really looking to see is where these points lie according to where they should lie on a normal curve. If the distribution is normal, all of our points should be more or less along this diagonal line. Of course, there's going to be some variability, but they should be fairly close to that diagonal line. Some software is going to give us confidence intervals. It gives us an idea when observations are well outside of that. And the confidence intervals are going to be based on how many observations. So when we look at this normal quantile plot, we're looking to see whether our observations are showing up right along that diagonal. Here we've got a pattern that's taking us straight across this diagonal. Don't really care for that. The last point is actually up here. And if you take a look at the pattern making that dog leg, it's probably not going to be normally distributed. We also have a goodness of fit test. And this is a statistical test that gives us a test statistic W and a p-value to go along with that. When we take a look at this statistical test, we've got to remember that the null hypothesis is that the data is normally distributed. Once again, the goodness of fit test, the null hypothesis, the residuals are normally distributed. We're only going to reject that null hypothesis if it's clear that they're not. P-value that we've got is 0.0016. That is a very small p-value. Notice it's got an asterisk after it. It says reject the null hypothesis. So based on this, we can say that this set of residuals is not normally distributed. So we have taken a look at the 4 regression assumptions. Let's take a look at the residuals of home sales by square feet. And once again, what we're doing with these residuals is we're taking our line, regression line, and rotating it to horizontal, bringing the points about that line along with it so that we are looking at these points relative to the model itself, not worrying about the slope. In other words, we're getting rid of the slope and focusing on what's left over. 4 regression assumptions: independent, expected value 0, constant variance, and normal. Independence, number 1. Do we see any patterns in these residuals? No, the residuals don't show any patterns, so independence is met. Expected value of 0. Are the residuals evenly distributed above and below the line as you move from left to right? It looks like they are. I don't see any curves, any patterns left in the data. So I think we can say expected value is 0. constant variance. Well, we've got little variance here, but it quickly picks up. And we might say that we've got a problem with constant variance. We might say that constant variance is met. It's a little difficult to tell with a sample of 13 because that is a relatively small sample. That small, if we ignore the fact that we've got 4 in a row right above in fairly small concentration, yeah, we might say that this passes. And I'm going to say that I think we're okay at this point, primarily because the sample is very small. Sort of like getting 3 heads in a row. Is that unlikely? Yes. Is it out of the realm of possibility? Not at all. Last thing we want to check, the distribution. Is it normal? Now we're taking a look at our histogram, and our histogram does a little bit better job of following that normal curve. We take a look at the normal quantile plot. Notice that these points are a little bit better distributed along that diagonal. So looking at this graphically, again considering sample of 13, not bad. When we take a look at the goodness of fit test down here, goodness of fit test, normal, null hypothesis is a normal distribution. We've got a large p-value, 0.33. That is not sufficient to reject the null hypothesis. When you take a look at this goodness of fit test, I want you to read the null hypothesis. This will be the same on every goodness of fit test. It reminds you, how do you interpret this? In conclusion, residuals are independent. We don't see any pattern. Expected value looks like it's 0. The variance is reasonably constant, and the residuals are normally distributed. Altogether, that means the form of the model is correct, and we can move on to step 5.